circulating water used every day just like a real crew member would. We do a comm delay based on our mission scenario. Appropriately, we'll phase it in, starting with maybe a 5-minute one-way comm delay up to a 10-minute one-way comm delay with the mission control support personnel. We observe them 24/7, just like you would be if you were on a real mission. So they're looking at the psychological effects of isolation and confinement. They're looking at the habitability. What do they need inside a module? They're looking at the medical equipment that may be needed. They're looking at any type of physiological countermeasure that may need to be introduced to keep the crew healthy and psychologically sound so that when they arrive at their destination, they're able to perform the tasks at hand.
Right.
So we need to answer all those questions and know them before we make that journey.
We're on a journey that started with the dreams and determination of men and women around this nation. A journey that set course from Florida's Space Coast. A journey of real innovators from California's Silicon Valley. A voyage of experimentation soaring above the Tidewater region and the high southern desert of California. One of humankind's greatest adventures, a magnificent journey that took vision from Texas to Ohio, from Louisiana to Alabama, and from all around this great nation. The start of anything substantial begins with a dream. From dreamers come documents and plans, onward to projects and field tests. That moment of execution comes as the dream lights up and literally bursts into reality.
Welcome to NASA, where every day at every NASA center, these dreams come true.
In offices, cubicles, hallways, hangars, and clean rooms.
On launch pads, in cockpits,
at desktop observatories, and continually
for more than 15 years aboard the International Space Station.
Investments in NASA are creating jobs across America.
From the Baikonur Cosmodrome in Kazakhstan, the trio will spend 6 months on the space station. NASA's Associate Administrator for Space Technology, Steve Jurczyk, was on hand for a recent media day at Made in Space Incorporated, an American-based startup company located at NASA's Research Park at Moffett Field, California. A Made in Space 3D printer was the first of its
coffee. I went to that Marvel movie marathon where you literally sit in the theater and watch everything.
Oh, leading up to the Avengers.
Yeah,
Age of Ultron. Oh, cool.
Like there's like 400 hours of footage and popcorn, and I'm sorry, I'm.
Well, we'll get it together because
Yes.
we have a jam-packed show, Franklin. We're going to be talking about Advanced Exploration Systems, or AES.
Yeah, and one of those technologies is 3D printing that is actually up on the International Space Station, Blair.
Yes.
Hey,
it's pulled together.
Later in the show, you're going to be talking with Deanne Bell with the futureengineers.org.
Yes, I am going to be talking to you.
And in the meantime, I had a chance to sit down with Jason Cruson, who is the head of AES, and he's going to tell us all about the cool technologies coming out of his office. Let's check it out. So Jason, I understand that you're the Q of NASA.
Well, that's an interesting reference in itself, but it's a nice analogy. If you think about Q was getting ready for Bond to go off and do whatever mission he was being charged to do. Our group is much like that. We're designing all the systems to send our crews off to explore deep space.
Now, within your portfolio or your technologies, what are you trying to develop?
So, a couple fundamental things. You need to be able to get into space, you need to be able to live in space and be productive when you're there. So we're building a lot of the stuff that allows you to live in space. So we are developing some of the next generation habitation systems. So where's the home? How are people going to live in that? Life support systems for it. How are you going to handle logistics and management of that overall being able to live in space?
Now, I guess, like, let's say when we go to Mars one day, we have the first humans on Mars. The first thing that comes to my mind is going to be spacesuits.
Absolutely. So we're also advancing the new spacesuits technologies. In spacesuits, we see you have what you see on the space station today. They go out, they repair something, they fix something, they come back in. On a trip to, say, Mars, you're going to potentially have to go out, fix things along the way, long duration there, and then when you get to the surface, you want to go outside.
Right. Now, one of the cool labs we have here at NASA Johnson Space Center is the Portable Life Support System Ventilation Laboratory, and that's where they're working on the spacesuits of the next generation.
Correct, yeah. So the suit is made up of two parts, the actual garment that you wear and then the backpack, the portable life support system. The life support system, the one we have, has been very reliable. However, it's getting pretty old at this point. And there's a lot of new technologies that we want to actually incorporate in the backpack of the future. For assembling the space station, or what we did on a shuttle, you're working in zero gravity, in near zero gravity. So the weight of the suit didn't really matter as much, the mass of the suit. But when you get to a surface, even though with the reduced gravity on Mars, you're still going to have to carry around that weight. So you're going to need a lighter weight suit, and also one that you can use more frequently, and also the one that puts up with the environment, the dust, the rocks, and all those kind of things. When we did those short duration EVAs during Apollo, we only did a very few number of them, and we were there on the surface of the moon for a very short time. On Mars, we're going to be there for a long time.
Mobility will probably be an issue. You said weight's an issue. Yep. The flexibility of actually working in that environment would be a key factor.
Correct, yeah. So a lot of the station assembly, they optimized the suit to working on the space station. So your work zones and such, you're not picking up things off the ground, you're not using hand tools and those kind of things. Instead, you're turning bolts and all that. So you have a different type of work that you're going to be doing.
Now, is there something with that backpack, is there something that you want to try to miniaturize it, they make it as small as possible? But on the flip side, you want as much oxygen for the astronauts to breathe to stay out there for extended periods of time on the surface.
Yeah, so you have this hard challenge of wanting to be out there as long as you can be out there and making it as lightweight as possible, which is what most people can relate to if anybody's ever traveled. You don't want to be carrying around a big heavy bag all the time either. So.
That's right, that's true. Now, what are some other cool technologies going on?
One of the problems we have is managing all the logistics. If you're going to be gone on a trip and you pack your car and you need to figure out where everything is going to be in, say, your motorhome over the course of a couple years, how are you going to find all that stuff? So what we're going to do is use next generation RFID, or what we call radio frequency ID tags.
Okay.
And what those allow you to do is wirelessly track and inventory where everything is inside of your vehicle.
I mean, that actually makes sense because especially you take a look at something like ISS, where you probably have thousands and thousands of pieces of equipment on the station, and how you keep track of all that.
And on space station, we don't sometimes. There are a number of items that we've lost on the space station, and we have to potentially fly a new one up. On the space station, you have the additive benefit of the crews changing every 6 months. So imagine if you were living in your house for 6 months, you put everything where you wanted it to go. Somebody else comes up 6 months later and moves it all on you. And then you come back again, and nobody knows where everything went.
Right.
So everything will have the equivalent of almost like a high-tech sticker that actually tracks every piece, and you'll have different types of readers. So you have readers that are in between modules, so you can track when something moves from one module to another, and you'll have other readers that may be handheld, so you can scan your storage bags and figure out which bag, and have folks here on the ground design it digitally, email the file up, and then print out the part on orbit.
And how long is that process in terms of making a tool or making a piece of technology?
So on station, we've already printed over 20-some parts. And in fact, you can print several parts per day, whatever you want, just on a single printer.
Franklin?
Hey, Franklin, what's the code for Q's lab?
You know, I'm not quite sure, but try this. It usually works for me.
All right.
Up, up.
Not really directions.
Down, down.
Got it.
Left, right. Left, right.
Yep.
BA. Select, start.
Mission complete.
Today we're at the Additive Manufacturing Lab at the Marshall Space Flight Center, and I'm talking with the 3D Printing in Space Project Manager, Nikki Werkheiser. How you doing, Nikki?
Hi, doing well, thanks.
Additive manufacturing, exactly what is it?
So additive manufacturing is actually the kind of formal term for 3D printing. Traditional manufacturing is subtractive. You have a material and you take away from it. Additive is any process really where you actually build the part that you're trying to create layer by layer. So it's additive instead of subtractive.
3D printing has been around for a long time.
That right now we're completely dependent upon launching from the ground to space station. So being able to create what you need when you need it on these type of missions is really a critical enabler to sustainable, affordable exploration missions.
Well, I've seen 3D printing work here on the ground, but to get it in space, what are the the technology hurdles that you have to get over to make sure it works the same way in space as it does here on Earth?
Right, so those were actually our exact questions. As a matter of fact, it was back in night that we just launched. It is the first 3D printer ever in space, and we launched it on SpaceX 4 recently. That's why it's called a technology demonstration.
Now on the table right over here, we have a replica of what is flying on the ISS right now. Exactly how does this 3D printer work?
So this first printer that we're flying, we're actually operating in the microgravity science glove box. And that is because since this had never been done in space before, we did not have all of the data for things like flammability and off-gassing of the heated extruded material that we're printing with. Since then, we've collected all that ground data and found that actually it's not. It's going to be science-backed very soon.
Tea Earl Grey hot.
What material is being used in the production of the parts that are going to be made on the ISS?
Sure, so for our first printer, the technology demonstration, we're actually using ABS plastic, which is the same plastic. If you see here, this is a little piece of the filament. This is the same plastic that Legos are made out of, for example. The filament that we use is just like this, and to be a proposal for a recycler on how to take that 3D printed part and turn it back into usable feedstock.
Nikki, what are the goals of this technology demonstration on the ISS?
So for the technology demonstration, it really has two phases. And the very first phase is specifically just to answer the question, does the additive manufacturing or 3D printing process work in microgravity the same way it does on the ground? So for the first phase, we'll actually be printing utilization parts. We have a broad range, and we're developing a utilization catalog. You can have things like sample containers, small hand tools, replacement parts for exercise equipment or medical tools. There's just a plethora of different areas and categories we're looking into. But the thing there is to learn how to design these parts and build them in microgravity and to create kind of a certification process happens on Space Station.
What's going to happen in the next generation of 3D printing in space?
Yes, so we're already working that, and everything that we learned from this technology demonstration, including what we've already learned from the design and the operations, getting it ready for flight, will feed into the next generation printer. The really exciting thing about the next generation is that it's going to be a commercial printer. It's called the Additive Manufacturing Facility, and it's being developed by the company Made in Space, and they're out in Silicon Valley. So it won't just be NASA or the government that has access to 3D printing parts in space. It will be available for use by industry and academia, small businesses, large businesses that are interested in making something in space. So I think it's very exciting to think about kind of opening that door and opening the door to the space station and able to manufacture parts in space to more people than just directly NASA.
This technology is awesome. And I got to tell you guys, in light of all the technology that we've seen in the show today, I've got something a little special that I've worked up with the help of our good friend Jarvis. We're going to talk to Deanne Bell. Hi, Deanne. Thanks for being on the show.
Okay, well, we're rolling and we're good to go.
Let's get started with a very important foundational question. What exactly is the Future Engineers program?
Right, so Future Engineers is a program that was started to really inspire the next generation of innovators and explorers. It's a website. You go to futureengineers.org, and there's all kinds of education resources. And our website challenges students to create 3D modeled inventions for space. The program is an American Society of Mechanical Engineers Foundation program in technical partnership with NASA, and it's really exciting. Our first challenge launched with the first zero-gravity 3D printer that went to space, and that's not the first and only challenge. We have many more challenges in the pipe, and we're constantly developing new challenges and new curriculum to really connect the excitement of space exploration and space research with the excitement of creating a 3D model and turning your idea into a 3D modeled reality.
Recently, you announced the winner for your first Future Engineers Challenge. What did that first challenge involve?
The first challenge, we challenged students to create a space tool for astronauts. And we had so many different submissions from all corners of the country. And ultimately, we chose 10 semifinalists in each age group. We had two age groups, under 13 and over 13, that are enrolled in a K-12 school. And our winner in the juniors age group is named Sydney Vernon, and she designed a space planter to grow a seedling in space. Our winner of our teen division, his name is Robert Hillen, based in Enterprise, Alabama, and he designed something called the MPMT. It's the Multi-Purpose Precision Maintenance Tool. And he basically took like a gajillion different tools and put it all into one to be 3D printed on station. And the excitement is, that one actually is getting 3D printed on station.
What's next for Future Engineers?
There is so much excitement going on with the Future Engineers program. We are growing. We are always in the process of developing new challenges. This program wasn't just one challenge with that first printer that went up. We're really focused on a multi-year endeavor of getting students creating their inventions and 3D modeling them in the computer. Every challenge that Future Engineers issues in partnership with NASA is going to be centered around research that's going on at NASA. So it's a really great opportunity to pair all the excitement in all the different areas of NASA research with K-12 programs to connect it with students in the classrooms.
How can students and Future Engineers get involved with the Avengers Initiative? Future Challenges. It's Future Challenges. How can they get involved in Future Challenges?
Right, so you can get involved just by going to futureengineers.org. The site's more than just a place to register and submit a model. There's all kinds of cool, fun goodies to explore. There's videos about how to get started in 3D modeling, how to learn about 3D modeling concepts. There's also all kinds of space science videos. There's different animated science lessons that you can learn about microgravity, about how rockets resupply the ISS. There's all kinds of content there to explore, so I strongly encourage students to go there, to just dive into the site and look at all the resources that we've curated for them.
Thanks, Deanne, and thanks, Future Engineers.
Thank you.
What you guys think?
Dude, that might very well have been the best interview you've ever done.
Franklin, I really appreciate that. Thanks so much.
As good as an Asgardian god.
Thor! That's awesome! R2!
You are great.
Willow!
Blair, 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 Blair.
Oh.
What's up?
Come on, man.
An outside look at all things NASA.
We lost a whole day because you were asleep. Next time, just see one film.
One film.
One film.
It does this to us all the time.
All the time. We have to shoot tomorrow morning.
It was good.
9 a.m.? Okay, 9 a.m. All right.
Dude, next time, bring your A game.
Get some sleep.
I thought that
And by the way, you blew it with the Avengers question.
Avengers question. Then it wasn't a dream. It was real!
Hi, I'm Jenny Devilites, and I am the Morpheus Lander Test Conductor and Systems Engineering and Integration Lead. Morpheus is the world's first prototype lander with liquid oxygen, liquid methane propulsion. One of the really exciting aspects of this project is that it's a rocket and it flies, and we get to light an engine and there is smoke and fire. From a team development perspective, there's a group of us that designed, built, and flew this vehicle. That's not an opportunity that you get every day, so that was always a very exciting thing to be able to do. But the long-term implications of it for the journey to Mars are even more important. The technologies that we're testing, we're trying to enable the types of capabilities that we're going to need down the road in order to get humans to Mars and back safely. And one of the important things is the integration of oxygen and methane with the rest of the system. Something very important about going to Mars is that you only have what you can take with you or what you can make on the surface. If you look at Mars, it's very dry, but you can extract water from the Martian soil. You can also create methane to fill the tanks of your ascent vehicle, and that's why part of what we did with Morpheus was so important to the Mars architecture.
It is often said that the only thing constant in life is change. That is as true at NASA as anywhere else. But the men and women of NASA generally see change differently than others because their life's work is all about change. Through their tireless efforts, these talented professionals move past the status quo every day and help us understand and change our world for the better. But even though change is part of their job requirement, the people of NASA understand that all projects eventually come to an end, and they will have to transition from one assignment and get ready for their next challenge. That transition is beginning to happen now for the members of the Environmentally Responsible Aviation Project. After 6 long years of study, team members are closing the books on the ERA research project that has provided so much new information about how future aircraft will fly. This team has worked diligently over the past half-decade to reduce aircraft drag by 8%, reduce aircraft weight by 10%, reduce engine-specific fuel consumption by 15%, reduce oxides of nitrogen emissions of the engine by 75%, and to reduce aircraft noise by 1/8 compared with current standards, all by the year 2025. These were stretch goals, to be sure, but not surprisingly, their efforts have paid off for all of us. Today, on NASA X, we will look at part 2 of this 2-part program that has explored the work done by the ERA team. We will look back at some of their early work while also looking at what some of the finished products look like. We will see how NASA and industry have worked together to improve the state-of-the-art for aircraft design, and we'll find out about promising new ideas that have come out of this work. Finally, we will bid farewell to the team that is changing the way we all fly. Created in 2009 as part of NASA's Aeronautics Research Mission Directorate's Integrated Systems Research Program, the Environmentally Responsible Aviation Project was tasked with exploring and documenting the feasibility of vehicle concepts and enabling technologies to reduce aviation's impact on the environment. Aircraft have benefited greatly by the work done by NASA engineers over the decades, but with changes in technology, NASA knew that much more could still be done. The ERA project was organized to mature promising technology and advance aircraft configurations that meet midterm goals for community noise, reduce fuel burn and nitrogen oxides or NOx emissions. They were also tasked with determining the potential impact of these advanced aircraft designs and technologies into the air transportation system. They have done all this and more. The solutions that they have achieved will undoubtedly reduce fuel consumption by up to several percentage points for the aircraft community. That may not sound like much, but shaving aircraft fuel consumption even a few percentage points can save millions of dollars and help protect the environment from harmful emissions. One area that the team focused on heavily to meet these goals was to develop, in collaboration with their industry partners, a new type of aircraft called the hybrid wing body concept. NASA planners did early wind tunnel tests and scale model tests with great success. The final phase of this testing is being done here at NASA Ames Research Center's 40 by 80 tunnel in California. The INFAC is actually home to 2 interconnected wind tunnels. One test section, the world's largest, measures 80 feet tall by 120 feet wide. The other one, the world's second largest, has a test section that measures 40 feet tall by 80 feet wide. This full-scale tunnel has been used since World War II and has helped perfect numerous aircraft designs and is now being used to help with this unique aircraft. Here is Kevin James from NASA Ames to explain.
If you take an airplane from, say, 1950, and you take an airplane from, say, today, and you lay them on top of each other, they have almost exactly the same outline. There have been a lot of improvements, but as we start looking for something that's dramatically different, where you're really going to make improvements in fuel economy, fuel emissions, and acoustics, say community noise and the impact that we have on how people live their lives, we have to keep looking and sometimes think outside of the box. So this is a hybrid blended wing body. We call the generic airplanes of today tube and wings. And that sort of makes sense because there's just a big old tube with a wing on it and we all just go along for the ride. What we've done here is we've actually taken that tube and with the abilities that we've had in improvements in structures and materials, specifically composites. We can now go from a tube shape to more of an elongated shape because the pressure vessel wants to be a tube and we want to kind of stretch it a little. Well, when we stretch it and then we blend the wings into it, we get this hybrid blended wing body airplane. And through very careful control of weight and very careful configuration control, including how you put the engines on it, we have significant improvements in fuel burn and also very significant improvements in noise. Our was a 50% reduction in fuel burn, gate to gate, and a 42 decibel reduction in noise in a cumulative fashion from a 1999 Target airplane. Where we ended up was really, really close. We made over 48% improvement in fuel burn, so missed it by just that much, and really close to we're at 40 dB down. Cumulative. But a good way to keep in mind what that really means is every 6 decibels of change is a doubling of the noise, our perception of the noise. So when we start talking about numbers like 42 dB down, even if it's cumulative, that is a huge improvement. What that really is in terms of quality of life for people in cities, especially around airports, is a significant improvement to what they've come to expect. It's been a lot of hard work. There's always frustrations, but that's kind of what makes the job fun sometimes, is solving the challenges. We have worked with some phenomenally good people. We are really truly blessed. NASA has hands down the best people on the planet. Just really good people. Smart, interactive, social, full of good ideas and wanting to solve problems. It has been a lot of fun seeing the pieces all come together, and ERA was laid out in a really kind of a very slick way. You've got the vehicle and the systems integration, you've got structures, and you've got the engine and propulsion. And again, to meet the stated goals, all 3 legs had to deliver. And as we get to the end of the program, it is just incredible seeing the progress that was made and the deliverables that we're getting from all of the components. And as they come together, you see that we are actually going to be able to be in a position to say something like this works. And this is where we should be headed.
The research from the hybrid wing-body aircraft will continue. And one day, in the near future, we may all see these types of revolutionary aircraft flying in our skies. Another concept the ERA team has been working on, called Active Flow Control Enhanced Vertical Tail Flight Experiment, has shown much promise as well. The ERA team worked in cooperation with Boeing to develop a plan to test this innovative idea in the wind tunnel and on an actual aircraft in flight. Before flight tests were done, the team installed 31 sweeping jet actuators onto a tail section of a 757 aircraft. These jets can manipulate, on demand, the air that flows over the vertical tail and rudder surfaces. This test is important because it has the potential to reduce the weight associated with the tail section. An aircraft's vertical tail is primarily used to add stability and directional control during takeoff and landing, especially in the event of an engine failure. But when the aircraft is cruising at altitude, the same large heavy tail is not necessary. Engineers theorized they could reduce the size of the vertical tail by using the sweeping jets to generate the same side force during takeoff and landing. That would reduce both the weight and drag of the airplane and decrease its fuel consumption. In order to test this large tail section, the team had to place it inside the NASA facility that is home to the world's largest wind tunnels, the National Full-Scale Aerodynamics Complex, or NFAC. Ground studies by a team of NASA, Boeing, University of Arizona and Caltech researchers on this full-scale 757 vertical tail in the INFAC did in fact show that the active flow control jets could potentially increase side force by as much as 20 to 30%. That low number of 20% increase in side force could allow designers to scale down the vertical tail by about 17% and therefore reduce fuel usage by as much as 0.5%. But this is not the only potential benefit. In addition to reduced weight and fuel economy, this type of device could also allow for new aircraft to use shorter runways. Here is the man who is called the father of active flow control, the University of Arizona's Iggy Wignansky.
We can possibly take off from a football field size with some sort of a rotor type airplane, maybe partly tilt rotor, partly tilt wing. And we can fly possibly at 350 to 400 knots and do this very efficiently. So since most of our flights are of the order of 1,000 miles, if you do it from downtown to downtown, from a parking lot to another parking lot, that's much more effective than to do it the way we do today. Because on a distance, let's say from here to Tucson, I spent about 2 hours at the airports, and this is not really necessary. And there are a lot of, by the way, small airports of runways that are less than 5,000 feet. They are in a lot of city centers or close to city centers that can be utilized and can be utilized effectively. So some sort of short takeoff airplane that would use this technology could be very effective.
After testing on the tail was complete at the INFAC, NASA and Boeing placed the tail on a Boeing test aircraft called the Eco Demonstrator. This aircraft is unique because it is being used as a flying test bed to evaluate different technologies that could increase efficiency. With the active flow tail attached, testing continued back at Boeing Field, with much of the research data being validated in flight.
Building on that 100-year collaboration we've had between NASA and Boeing, the Eco Demonstrator program really is about continuing that legacy and spurring some more action to see that continued collaboration together successfully.
This collaboration and testing is important not only because technology must move forward, but because of the significant savings this could potentially afford aircraft operators and the flying public.
When you think about the worldwide fleet of airplanes, there are about 18,000 airplanes that fly today. And it's projected to grow to 36,000 airplanes in the next 20 years. So if you can get a little bit of improvement on one airplane, and it's multiplied times 36,000 in the next 20 years. So it's huge improvements with regard to reducing overall fuel burn.
Having a relevant test bed like Boeing's Eco Demonstrator is helping to mature technology concepts that have been extremely important to NASA's environmentally responsible aviation project. Researchers have been working hard to develop technologies to reduce airplane fuel consumption, noise, and emissions. Being able to prove those concepts in flight tests gives them a better shot of getting into the commercial fleet. Because the Eco Demonstrator was designed to test multiple experiments at once, Boeing and the ERA team also decided to test special material coatings on the right wing of this aircraft that could reduce bug contamination. This test was called the Insect Accretion and Mitigation Experiment, which in layman's terms means that it is simply an experiment to test how to keep bug guts from reducing aircraft efficiency. It might seem odd that NASA would spend its time worrying about seemingly innocuous bug strikes, but believe it or not, these small creatures can significantly reduce an aircraft's efficiency. In a set of flight tests near Shreveport, Louisiana, the team assessed how well 5 different coatings repel insect residue. Studies have shown that keeping the flow smooth or laminar over a wing can reduce fuel consumption as much as 6%. Even something as small as a bug on a leading edge can cause turbulent wedges that interrupt laminar flow. That results in an increase in drag and fuel consumption. Engineers at NASA developed and tested a number of nonstick coatings in a small wind tunnel back at NASA Langley. Their initial findings allowed them to reduce the number of material from about 20 test samples down to 5. With these 5 best candidates in hand, the team was now ready to place the samples on the right wing of the Eco Demonstrator for flight validation. The next step was to find the best bug-infested area in which to flight test the surfaces. After narrowing the list of 90 airports to 6, Shreveport, Louisiana was chosen due to its temperature, geology, runway size, and potential for large numbers of bugs. During 15 planned flights, researchers installed sections of coatings onto the leading edge slats of the Eco Demonstrator 757. First, they established a baseline using uncoated surfaces to capture insect accumulation rates. Then they removed those sections and installed samples of the 5 treated panels. One of the things engineers want to test is how durable the coatings are. Treated surfaces will only be effective as drag reducers if they can withstand the harsh flying environment.
So what we're doing here is testing some of the coatings that we developed to prevent bugs from sticking to aircraft wings. This has been about a 5-year effort, and we started in the lab knowing that the problem is that if bugs stick to aircraft wings, you affect the laminar flow and therefore fuel efficiency. So we've taken samples, designs of material coatings from the lab to wind tunnel tests, and we finally have the big test, which is testing it on an actual aircraft, and so that's what we are here to do. What we do is we mount our samples onto the wing of one side of the aircraft, and we designed the test so that half of the panels are untreated that are mounted, and half of them have the surfaces that we are flying. And so what we do is have several takeoffs and landings, because those are the parts of the flight profile where you actually accumulate bugs. And so what we want to do is test to see if the coatings that we developed actually reduce the number of bug strikes that you get, and that's why we fly together with the untreated coatings. And the reason we're interested in that is because an aircraft is designed for cruise. But in order to get to cruise, you gotta pass by takeoff and landing, which is when the bugs are going to accumulate. And so you basically negate the effect of designing the aircraft to benefit from being in cruise, because you already have the bugs by the time you get to cruise. That's why we have to do a lot of takeoffs and landings, because those are the parts of the flight where we actually have the problem. What we hope to accomplish is that the flight test confirms what we actually saw in the lab, right? So we tested over 200 different compositions in the lab, in a small-scale bug gun, in the wind tunnel, and actually even in a small aircraft. We've down-selected to 5 compositions. If any one of those, or at least one of those, actually works in practical application on the aircraft, which means that we've significantly reduced the number of bugs sticking to the surface, and where they stick is not a critical location to trip the flow, then it would be a success, right? This is actually a long-standing problem. We've seen literature all the way back to the 50s trying to solve this problem. And so if we're able to have a solution based on current understanding of what makes things stick and not stick, that'd be a huge success.
Testing also continues on this unique application, and early results have shown that the ideas that have been generated may possibly work to reduce bug strikes on future aircraft. These are just a few of the innovative
Hi, I'm Jim Green, Director of Planetary Science at NASA. You know, NASA works with the international science community to explore our solar system and beyond. We look to unravel the mysteries that intrigue us all as we explore and answer the big questions. Questions like, how did the Earth originate and change over time? How did the solar system begin and evolve? And what will be its destiny? What will be our destiny? Last July 14th, NASA's New Horizons spacecraft flew past Pluto, capping a half-century of exploration of our solar system. It piqued our interest about what lies beyond Pluto and what can we learn about ourselves and the origins of our solar system. The idea of a new planet is certainly an exciting one for me as a planetary scientist, and I think for all of us. The January 20th paper in the Astronomical Journal is fueling our interest in planetary exploration and stimulating a healthy debate that's part of the scientific process. I couldn't be more pleased about what's happening. You know, it's all about starting the process that could lead to an exciting result. It is not, however, the detection of a new planet. It's too early to say with certainty that there's a so-called Planet X out there. What we're really seeing is an early prediction based on modeling from limited observations. What's exciting is that, like NASA's Journey to Mars or New Horizons flyby of Pluto, you will have a front row seat to see how the scientific process unfolds. Theories like this serve to stimulate ideas and conversation. They tap into our innate curiosity. It's important for us to continue to work, and we will. Anytime we have an interesting idea like this, we always apply Carl Sagan's rules for critical thinking, which include independent confirmation of the facts, looking for alternate explanations, and encouraging scientific debate. If Planet X is out there, we'll find it together. Or we'll determine an alternate explanation for the data that we've received so far. Now, let's go explore.
Esta es Lola de Plaza Sésamo y Lola está feliz, feliz porque le encanta vivir muchas aventuras con sus amigas, Diana y Sandra. ¡Ay! Porque ellas son realmente ingenieras de la NASA. ¡Ay, sí! Y trabajan en Marte. ¡Wow!
Bueno, Lola, nosotras no estamos en Marte físicamente.
¿No?
No, Lola, pero sí tenemos robots que están en Marte. Tenemos a Maven y tenemos a Curiosity.
¡Wow! 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 ¿Y cómo puede Lola aprender más sobre eso? ¿Cómo?
Aquí mismo, en NASA TV, Lola.
¿Aquí y ahora?
Sí, Lola, estás directo. Ve y di hola.
Ah, sí. ¡Hola! Sí, estás viendo NASA TV.
And determination of men and women around this nation. A journey that set course from Florida's Space Coast. A journey of real innovators from California's Silicon Valley. A voyage.
Hi, I'm Neil deGrasse Tyson, and you're watching NASA Television.
This is Mission Control Houston. 14 hours and 58 minutes into the 47th expedition to the International Space Station. New expedition extending the world's work in space is underway as the on-orbit portion of the one-year mission goes into the record books. Right now, the International Space Station is flying in good shape in orbital darkness, about 249 miles above the Tasman Sea, east of Sydney, Australia. It's currently headed to the northeast for transit across the Pacific Ocean and should be west of the coast of Oregon about half an hour from right now. On board the space station, the 3 crew members are all either off duty or still asleep. They are shifting their wake-sleep cycle back to normal following the Soyuz undocking operations that took place on Tuesday. The next wake-up alarm is not actually set to go off on board the space station until Thursday morning, midnight Houston time. Today is the 79th day in space for the Expedition 47 crew members. NASA astronaut Tim Kopra, now the commander of the space station, joined by flight engineers Yuri Malenchenko of Roscosmos and Tim Peake of the European Space Agency. They've been in space since their launch from the Baikonur Cosmodrome back on December 15th. Expedition 47 will extend into early June. Right now, the International Space Station Flight Control Room is the home for operations of the Orbit 2 team of flight controllers, a team that is standing by, keeping track of the operation of station systems, and will be ready to work with the crew members if anything comes up for them today. Flight Director Zeb Scoville is in charge of the team today. No spacecraft communicators currently at the console, since the crew members are technically are asleep. It has been a quiet day in Flight Control Room 1 today, after a very busy day and evening yesterday that saw the end of Expedition 46, the safe landing of a Soyuz spacecraft with 3 crew members on board, and the final hours on orbit of a 340-day flight by NASA astronaut Scott Kelly and Roscosmos cosmonaut Mikhail Kornienko. It's the longest flight ever by crew members on the International Space Station. We pick up the story on Tuesday afternoon.
And some quick words from the Soyuz commander Sergei Volkov, who's bringing the 2 one-year crew members home first, and then Yuri Malenchenko there on the left, just also offering his congratulations and his thanks to the 3 getting ready to depart the International Space Station. Again, Scott Kelly and Mikhail Kornienko wrapping up 340 days on board the orbiting laboratory. For Sergei Volkov, 181. He's going to be commanding the Soyuz craft through tonight's activities and the descent back down to Earth. But definitely a pretty significant moment for the departing year-long crew members who have been on board the International Space Station since March 27th of last year. So obviously very big steps for them to now depart what's been their home for the last roughly 12 months and get ready to make their way back down to Earth, its gravity, their families, and life as it was over a year ago. Sergei Volkov doing one final wipe down of the sealing ring around the Soyuz hatch before he closes it. And undocking has occurred 7:02 p.m. Central Time. It's 8:02 p.m. Eastern Time. while the station was flying just over the eastern part of Mongolia. So the Soyuz TMA-18M spacecraft undocked from the International Space Station. Mikhail Kornienko, Scott Kelly, Sergei Volkov on their way home.
TC-7 is illuminated. Copy.
The visiting vehicle officer here in Houston getting confirmation everything went well with that second separation burn. Soyuz TMA-18M with the one-year crew on board now departing the area of the International Space Station. There you can see the orbiting laboratory in full view from the camera on board the Soyuz craft, which again undocked from the space-facing side, so getting a great look straight down at the station and the Earth below. Both spacecraft right now just over the very far eastern part of Russia, about to well north of the Sea of Japan.
S-18 is being issued.
And this was what we were waiting for. We actually have replays now of the Soyuz spacecraft as it was under parachute. This view coming from one of the Russian Mi-8 helicopters, which was circling the landing zone, waiting for the Soyuz craft to descend. And here you can see it. This is a replay from just under an hour ago as the Soyuz spacecraft was descending under parachute. You can see the thick cloud cover in the overcast sky, but a beautiful light. The Soyuz landing just a few hours after sunrise in Kazakhstan. This again a recorded view from one of the Russian search and recovery helicopters. And so at this stage, the Soyuz capsule was well under its main parachute, a massive parachute designed to slow the Soyuz down from a descent rate of 80 meters per second to just 7.2. The parachutes being initially opened at an altitude of about 6.6 miles. You can see the capsule descends upright. Occasionally will land and roll over on its side, but in this case the capsule landed upright. So it made things easy for the search and recovery forces.
And Dan, they're helping him down this little slide ladder, if you will. He'll be carried into the center seat of the three comfortable chairs that are set up in front of the cameras. He'll be getting a very clear view of that. And the recovery personnel is now bringing Sergei Volkov to the center seat. As you know, he was launched back in September with a visiting crew, a Kazakh cosmonaut and a Danish astronaut who spent a short time aboard the International Space Station.
Careful, please don't stand in front of the camera.
Scott Kelly. Scott Kelly back on Mother Earth after 340 days in space, Dan. Thumbs up.
We got a great view of him now. The folks here in Mission Control Houston letting out a very big cheer. Scott Kelly, as you just said, returned after 340 days in space. NASA's one-year crew member conducted a lot of very important research back down on Mother Earth, back down in Kazakhstan, where he launched from just about 12 months ago.
With the camera. Over here, please. And don't interfere.
And we're seeing a big smile from Scott Kelly there. You can see just to his right, Steve Gilmore, Scott's prime flight surgeon for his year in space. No stranger to cold landings in Kazakhstan. This is his fourth mission, his second landing in a Soyuz. 520 total days in space across his space flight career, 340 days in this historic year in space.
And then Scott just looked at us and said, the air feels great out here. I have no idea why you guys are all bundled up.
With temperatures hovering right around freezing, I imagine you guys are thankful for your jackets, but for somebody who hasn't had the breeze on his face for almost a year, I bet it feels pretty great out there right now. And back over at the capsule, we can see Mikhail Kornienko, the other one-year crew member, outside the capsule getting ready to get carried over as well.
Do you work for Mission Control?
And Dan, Scott Kelly absolutely relishing the fresh air out here in the mid-morning hours here in the southern steppe of Kazakhstan, breathing deeply, enjoying every second of his return to Earth.
And we just saw Mikhail Kornienko go down the slide. He's getting carried over, so he'll be joining you shortly as well. So with that, all three crew members out of the Soyuz capsule safely down there on the steppe in Kazakhstan.
1 year mission, guys. I'm fine. Yeah. Is it the old tradition?
And Dan, very swift work made by the Energia folks. Sergei Volkov, just a few feet away from me. His father is kneeling down right next to him. What a picture that is. Father and son, cosmonaut heritage that has spanned several decades of Russian space history.
Everything as we were taught.
And we just had a great view of that. Saw Scott Kelly with a satellite phone in his hand, assuming making a call to friends and family, eagerly awaiting his return here to Houston, just about 24 hours away or so from now. A lot of smiles from all three crew members now safely out of that Soyuz vehicle.
Well, you see, just let me go to a sauna down here and then I can fly again. Alexander, hello. Please pass along our thank you.
Right now we're looking at Mikhail Kornienko and the other crew members, where you can see the various flight surgeons and nurses out there with the search and recovery forces affixing a number of devices just to get those initial medical readings from the crew members.
Chairman of the State Commission, the Soyuz crew is here. The flight program has been fully executed. Glad to report. Glad to see you back. Glad to see you back. Welcome home. Thank you.
Ой, меня немножко чего, ребята. Давай в автобус. Всех не поцелуешь. Юрик. Все, здорово еще раз.
Пожалуйста, спуститесь.
Those last scenes, we saw Sergei Volkov and Mikhail Kornienko returning to the airfield in Star City, getting back to their home, being greeted by many fellow cosmonauts and their family. Scott Kelly is en route home too. He is on a NASA aircraft en route back to Houston, and currently expected to land at Ellington Airport near the Johnson Space Center about 9:30 Central Time tonight. NASA TV coverage will provide live coverage of Scott Kelly's homecoming to Houston tonight. We expect to go on the air about 9:15 Central Time this evening. We also have 2 news briefings scheduled for Friday afternoon. At noon Central Time on Friday, we'll have a discussion of the science of the one-year mission and the twins study with Space Station Program Chief Scientist Julie Robinson, Human Research Program Chief Scientist John Charles, and former astronaut Mark Kelly, Scott Kelly's brother, who participated in the twins study. At 1 o'clock on Friday, Scott Kelly will be on hand to talk about his mission and to answer questions. Now, much of the research that was conducted for the one-year mission of Scott Kelly and Mikhail Kornienko focuses on how the human body reacts to being in the microgravity environment of space over an extended period of time. Over the next few weeks, Space Station Live will highlight several of those investigations. My colleague Lori Meggs is at the Payload Operations Integration Center at NASA's Marshall Space Flight Center in Huntsville, Alabama, with more. Good morning, Lori.
Good morning. Scott Kelly may be back on Earth, but when it comes to research, his work is not done. I recently spoke with a principal investigator